Hi, hello friends. Welcome to Chindu Smart Class. Today we are going to discuss about Euclidean algorithm. What is the purpose of Euclidean algorithm? Euclidean algorithm is used to find the GCD. GCD means greatest common divisor. GCD. Greatest common divisor. Okay, so what is GCD? GCD means it is the largest integer that can divide both integers. Okay, this is the GCD means it is largest value, it can divide both integers. We need to give two integer values and we need to find a GCD of those two values. Okay, so here we need to find divisors of both values, and you need to find the common divisors of both values, and out of all the common divisors, what is the greatest one? You need to pick the greatest divisor. Okay, for example, if you take some 12 and 20, so what are the divisors of 12? 1, 2, 3, 4 and 6 and 12. These are the divisors of 12. 1 can divide 12, 2 can divide 12, 3, 4, 6 and 12. And what are the divisors of 20? 1, 2, 4, 5, 10 and 20. Okay, these are the divisors of value 20. Okay, out of all these divisors, what are the common divisors? You need to take common divisors. 1 is the common divisors. 1 is available in both lists, 1, 1 and 2, 4, that's all. Okay, so 1, 2 and 4. Okay, so these are the common divisors. These are all common divisors. Okay, so out of common divisors, you need to pick the greatest one, largest value. This is called GCD, greatest common divisor. Okay, so you are already aware of GCD, I think. So GCD, to find the GCD, it is very simple. If the two values are small, we can find the GCD with this process. Okay, if the two values are like 12,560 and 13,760, like this, then how can you find GCD of these two values? It is impossible. Okay, so it will take huge amount of time. So what is the solution for this? The solution is Euclidean algorithm. Okay, so Euclidean algorithm, when we use Euclidean algorithm, the two values are large. If you want to find the GCD of two large integers, then we need to go for the Euclidean algorithm. Okay, so it is developed by Euclid. So it is called Euclidean algorithm. So basically this algorithm depends on two facts. Okay, we need to follow two facts. What are those two facts? Fact 1, GCD of a comma 0. is equal to a. This is fact 1. GCD of a comma 0. The second integer value is 0, then GCD is a. Okay, and fact 2. GCD of a comma b is equal to GCD of b comma r. Okay, where what is r? R means remainder of dividing a by b, okay. So it is remainder of dividing a by b. We need to continue this process until the second value becomes 0. Okay, we need to continue this process. GCD of a comma b is equal to GCD of b comma r, and again if the value is not 0, then again you need to follow the same procedure until the second value becomes 0. Okay, so whenever the second value is 0, then you need to take the first value as GCD. Okay, GCD. Understood? So fact 1 is GCD of a comma 0 is equal to a. Second value is 0. Okay, that's why we take a is the GCD. Okay, and second one, GCD of a comma b is equal to GCD of b comma r. R means remainder of dividing a by b. Okay, we need to continue this process until we reach the fact 1. Fact 1 means second value is 0. If the second value is 0, we need to take the first value as the GCD. Okay, so this is like a recursive function. Okay, so recursive algorithm, this is the base case and this is the recursive case. Okay, fact 1 base case, fact 2 recursive case. So I hope you already know about recursive function. So base case and recursive case. Recursive case, you need to continuously do the recursive case. You need to continuously follow the recursive case until the occurrence of first base case. I mean until the occurrence of first case. Okay, so these are the two facts we need to follow in Euclidean algorithm. So for example, GCD of 36 comma 10 is equal to, so this is fact 2 because the second value is not 0, so we need to follow the fact 2. GCD of a comma b is equal to GCD of 10, b means 10 comma, what is our remainder? 6. Okay, 36 mod 10 means we will get 6, so 10 comma 6. Again you need to follow the fact 2, GCD of 6, GCD of 6 comma remainder 10, 10 mod 6, 4. Okay, and again GCD of 4 comma remainder 6 mod 4, 2, and again GCD of 2 comma 4 mod 2, 0. Okay, with this we need to stop this iterative process because second value is 0. Okay, so second value is 0. When second value is 0, we need to take the first value as GCD. So GCD of 36 comma 10 is equal to 2. Okay, so while finding the GCD of 36 comma 10, we also get the GCD of 10 comma 6. This is also 2. GCD of 6 comma 4, 2. GCD of 4 comma 2, 2. Okay, so this is the procedure to follow GCD of some two values. Okay, so we need to follow fact 1 and fact 2. So what is the algorithm, actual algorithm? This is the process. We need to represent this process with a algorithm. So suppose we need to, if you take first value R1, we take a value in R1 and B value in R2. Okay, while we need to repeat the process, so that's why we are taking the while loop. So until the second value becomes 0, we need to repeat the process. Second value means R2. Okay, so R2 greater than 0. Okay, we need to repeat the process until R2 greater than 0, until whenever the R2 is 0, then the while loop will break. Okay, it will come out of the loop. So here first we need to find R1 divided by R2. R1 divided by R2, that is the coefficient, and we need to find R value. R means remainder. Okay, how can you find the remainder? R1 minus coefficient into R2. Okay, so this is the equation to find the remainder, R1 minus Q into R2. Suppose for example, if you take 36 comma 10, this is R1 and this is R2. How can you find the remainder? R, which is equal to R1, that means 36 minus, what is the coefficient? 36 divided by 10, 3. Okay, 3 into 36 divided by 10. Okay, so this is 30 and this is the remainder, and this is called coefficient and this is called remainder. How will you get this value? Remainder, 36 minus 3 into 10. 36 minus 3 into 10, 10 is equal to 6. Okay, so that's why we take this formula, R1 minus Q into R2. And next, here we are finding remainder. Okay, we are finding the remainder, 36 and 10, so we get the remainder 6. So after that we need to find the GCD of 10 comma 6. We are taking the second value as the first value here, second value as the first value. Okay, and the remainder as the second value. So you need to follow this process. That means R1, okay, so R1 is equal to R2, and at the same time R2 is equal to R. Okay, so second value will become first value and remainder will become second value. Okay, we need to continue this process until R2 becomes 0. After that, we need to store that value GCD of A comma B. Whenever it will come out of the loop, then that means GCD is R1. Okay, first value. Second value will become 0, then first value is GCD. So this is the algorithm with the diagrammatic representation. R1 is equal to A, R2 is equal to B, okay, and R remainder. Okay, so we need to follow this table, we need to write this table in exam also. In next process, we need to bring R2 as R1, okay, and R as R2. Okay, so need to continue this process. R1, R2, 0. Okay, R1 and 0. Okay, so this will take as GCD of A comma B. Okay, so you need to write this table. In the table format like this. Like this. Suppose, for example, if you take 36 and 10. So what are the example we have taken? So how to represent the in table format? So R1, R2, R, okay, and one more one, Q, coefficient. I am taking coefficient also. So R1, R2, 36, 10. So 36, 10, these are two values I have taken. Coefficient 10 is 30 and the remainder is 6. Okay, after that we need to make R2 as R1 and R as R2, 6. 6 ones 6 and the remainder is 4. Okay, and next 6, 4, 4 ones 4 and the remainder is 2. Next 4, 2, 2 twos are 4 and the remainder is 0. Okay, and next 2, 0. The second value here, see, second value is 0 and that's why we take the first value as GCD. Okay, This is GCD of 36 comma 10, that is equal to 2. Okay, so with this we have completed Euclidean algorithm. If you learn something from this video, please like, share and subscribe. Thanks for watching.